In our forensic fingerprinting activity, we explored multiple methods to make latent fingerprints visible on various types of surfaces. Each method demonstrated how different chemical or physical processes interact with the natural residues left behind in a fingerprint, such as amino acids, fats, and oils. These activities taught us the importance of choosing the appropriate technique based on the nature of the surface and the fingerprint itself. Ninhydrin-Acetone Method. The first method we used was the Ninhydrin-Acetone Method, ideal for porous surfaces like bond paper or notebook paper. We prepared the solution by dissolving ninhydrine powder in acetone. Using a tray, we submerged the paper containing latent prints into the solution. After that, we used an iron to dry it more quickly. The heat activated the chemical reaction between the ninhydrine and the amino acids present in the sweat of the fingerprint residue, forming Rohmann's purple, a deep violet color. This reaction revealed the ridges and patterns of the previously invisible fingerprint. Ethanol-Ninhydrin Method. Next, we tried the Ethanol-Ninhydrin Method, which followed a similar procedure, but used ethanol as the solvent instead of acetone. Ethanol is less volatile and less harsh, making it suitable for delicate or older documents. We submerged the paper with latent prints into the solution, allowed it to dry for a while, and applied heat using an iron. After a few minutes, the same purple-colored fingerprint patterns appeared. Both ninhydrine methods proved effective in revealing prints on porous materials. Iodine-Crystal Fuming. For non-porous or semi-porous surfaces like papers or index cards, we used the Iodine-Crystal Fuming method. Iodine crystals were placed inside a tin container, and the paper with latent prints was placed over the opening of the container, exposing it to the fumes. As the iodine sublimated into vapor, it reacted with the oily and fatty components of the fingerprint, revealing brownish or yellow-brown patterns. These prints became visible within minutes, but were temporary and began fading shortly after exposure. We immediately took photos to preserve the evidence. Victoria Blue on leaves and receipts. We also used Victoria Blue dye to develop fingerprints on challenging surfaces such as leaves and thermal receipts. The dye was prepared in a solution of ethanol and water. On leaves, the dye adhered well to the waxy coating and highlighted the ridges in blue or bluish purple. On thermal receipts, the dye was applied carefully to avoid damaging the surface. The result was a vivid, high-contrast fingerprint image. This method was especially effective for highlighting prints on non-porous or delicate materials. Black powder, swing method and brush method. In addition to chemical methods, we also used physical development techniques with black fingerprint powder. In the swing method, we placed a small amount of black powder into the paper containing the latent print. We gently swung the paper so that the powder would disperse and settle on the fingerprint residue. After a few swings, the ridges began to appear as the powder adhered to the moisture and oils in the fingerprint. In the brush method, we used a soft fiberglass or camel hair brush. We dipped the brush lightly into the black powder, then gently twirled or brushed it across the surface using circular motions. The fine powder clung to the fingerprint ridges, making them stand out clearly against the surface. Once the print was developed, we carefully lifted it using adhesive lifting tape and transferred it onto a fingerprint backing card for documentation. This method worked best on non-porous surfaces such as glass, plastic, and metal. Through these diverse fingerprint development techniques, we learned how forensic investigators adapt their methods depending on the type of surface and the nature of the fingerprint residue. Whether through chemical reactions or physical powders, these techniques made invisible evidence visible, helping link individuals to objects or crime scenes. This hands-on activity helped us understand the science and sensitivity involved in fingerprint development, which is an essential skill in forensic identification and criminal investigation.